Welcome to this class on electric fields, and in this section we are going to deal about the new concept on electric fields, a very interesting concept. And in this slide we can see the comparison between the gravitational force fields and the electric fields. So we all know that the mass acts as a source for the gravitational force, and force due to gravity can be given by mass into gravity. And similarly, for electric fields, we can see that the charge, that is a positive or a negative charge, they acts as a source for electric fields. And from Coulomb's law, we can say that the force due to the electric field can be given as Q into E, where Q is a charge and E mentions the electric field due to electric field in the medium. And so we say that there are two types of charges. One is the positive charge, another one is the negative charge, and this positive charge acts as a source for electric fields, and the negative charge acts as a sink for the electric fields. We look at this animation where it shows the nature of a positive charge, and this red ball looks like a positive charge, and we see that the electric fields are simply emerging out of. And now look at this animation. We have a green ball in which it acts like a sink for the electric fields. That is, the electric fields, it collects all the electric fields. So what we understand that the electric fields starts at the positive charge and converges at the negative charge. So this animation best explains the nature of the electric field, which starts at the positive charge and concludes and then sinks at the negative. We look at this animation. I have two charges here. Initially I am going to take the two charges of zero magnitude. First I am going to give a magnet of 1 to the charge 1. We see that electric fields are coming out. That is, it is a source. Now I am going to convert it to negative. We see that it is converging. That is, the fields are coming towards the charges. And now I am going to modify this as 1, and I am going to replace the other charge as -1. So what is happening? So we see that the electric field starts at a positive charge and it ends at the negative charge. In case if I have two like charges, we can see in this area the electric fields are repelling each other. There is a repulsive force created between the two like charges, and the same I can visualize in this animation also. So that means if I am going to replace it with 1, you can see that the fields are coming starting from here and also starting from here, and here we experience a simple repulsive force where there is a diversion. So at the same time you can see this using this Grassfield seal, where you can see a repulsive force, and the similar is the case for if both are negative. See, this is what happening. Again we can see the same concepts here, and that is, again we can see the repulsive force between the two, the same nature of repulsive force between the two charges. With this concepts in background, we are going for this voting concept. So this question I want you to think and vote, give your vote for this one. So you can see that there is a vector field. What is the combination of this one? So that is, it may be two sources of equal strength, and two sources which one that is top bottom stronger, and two sources which bottom stronger, and it may be a source or sink with equal strength, a source or sink where top is stronger, and source or sink with bottom stronger. And finally some of you have the very familiar choice of I don't know. I wanted to start and give your voting by raising your hands according to this. So I understand that most of you are able to give the correct answer. That is, it acts like a two sources. Very good. At the same time, and if majority of you are able to give the answer as in which the bottom is stronger and the top is less. Very good, very good. So with this background we are going for another concept. Now I have an example here like this. There are two charges, but they are not equal polarities. They are of different polarities, in which one is 5 times larger than the next one. The question for you to think and discuss is this one. There are three possibilities. The point of zero field should be where the point of zero field will be located. The point of zero field will be between the two points, and the next possibility may be the point of two charges the point of zero field is located on the left side of the left charge, and the third possibility, the point of zero field locates at right side of the right charges. I want you to think this and give the answer. There is 2 minutes for you to think and give me the answer, and keep the answer with you. Sorry, give the answer with you. Yes, the 2 minutes over, and now you can discuss your answer with your partner and neighbor who is beside you, and share your answer. And also, while sharing, please explain how you could come to the conclusion out of the three choices. Ask your neighbor to explain the answer and also share his or her view. Don't stop with, if you both of you are correct, if you have the same answer or different, don't stop with one. Check the other possibilities also. And now come to the conclusion which is correct. Now you have 5 minutes time for this one. Now it's a time I want you to vote. Yes, voting will be done. Yes, I find that those who chose answer 1, please come to the stage and explain. Fine. And those who are in the voter for 2, please come to the stage and explain. Fine. And now we go to this animation again, and we'll look at the correct. So we see that the two charges are of equal magnitudes. Now I'm going to raise this by 5. So this one is 5 times larger than this one. So you see that this is, the fields are starting and ending, so it acts like a so-to sink relationship, and there is no field charge here. And also the fields are diverging here, there is no field here, there is no 0 point here, and here we can see that there is a convergence and divergence. So possibility the 0 field should be located in this area. So from this we can come to the conclusion. So where to look? So from this animation I can come to the conclusion that this field should be on the right side of the right charge. Thank you.